Hey everyone, in generative function I already discussed what is generative function, different formulas of generative function and lots of example. Let's see some more examples of generative function. Example 9, solve the recurrence relation ak equals to 3a k minus 1 for k equals to 1, 2, 3 till infinite and the initial condition a0 equals to 2. So you need to solve this recurrence relation ak equals to 3a k minus 1 using the generative function. We know generative function formula. If gx is the generative function for the sequence ak, then gx equals to summation of k equals to 0 to infinite ak x power k. And here it's given ak equals to 3a k minus 1. So what we will do, we will also find xgx. Xgx means we are multiplying x before gx. So here we will multiply another x. Here k, here 1. So it will be x power k plus 1. Rest all are same. So summation of k equals to 0 to infinite ak x power k plus 1 as we are multiplying one x. Okay. Next we can simplify it. Here limit is k equals to 0 to infinite, that we can change to k equals to 1 to infinite. K value reduced. So a k minus 1 x power k. So from this we'll reduce minus 1. So a k minus 1 x power k. Before it was k plus 1. Now k after taking limit k equals to 1 to infinite. Now we have the recurrence relation ak equals to 3a k minus 1. So what we will find, gx minus 3x gx. Okay, why 3? Because here it is 3, right? It you can write as ak minus 3a k minus 1 equals to 0. This is our recurrence relation. So due to this 3 we multiplied with 3. We know the gx value. Gx equals to k equals to 0 to infinite ak x power k minus 3 xgx value. Xgx value equals to k equals to 1 to infinite a k minus 1 x power k. So we write gx value and xgx value. Now we need to compare these two. Here limit is k equals to 1 to infinite. Here limit is k equals to 0 to infinite. So what we will do, from this first term we'll take 1k out, means we'll take a0 out. After taking a0 out, this limit will be from k equals to 1 to infinite. So it's like a0 plus summation of k equals to 1 to infinite ak x power k. Okay. After taking a0 out, we got a0 plus k equals to 1 to infinite ak x power k minus 3 multiplied summation of k equals to 1 to infinite ak minus 1 x power k. So from this we can take common summation of ak minus 3ak minus 1 whole multiplied by x power k, and this we know as 0. Here it's given, right? So this thing is 0. 0 multiplied with this, so whole term is 0. a0 value is 2 as it's given in initial condition. gx minus 3x gx. Now from these two we can take gx common. After taking gx common, 1 minus 3x equals to 2, and this is the solution of this recurrence relation. Let's see another example. Example 10, coefficient of x power 20 in the sequence x power 3 plus x power 4 then whole power 5 is dash. So you need to find what is x power 20 value from this sequence. So x power 3, x power 4, x power 5 till infinite whole power 5, that we can write as x power 15, 3 multiplied 5, then 4 multiplied 5, x power 20, 5 multiplied 5, x power 25, like this infinite. From this sequence we can take x power 15 as common. After taking x power 15 common, we got x power 15, 1 plus x power 5, 5 plus 15, 20 plus x power 10, 15 plus 10, 25, like this till infinite. So x power 15, then from this sequence we can take power as 5. So 1 plus x square till infinite power 5. This is a geometric sequence, and for this we know the formula. So apply this, it will be 1 by 1 minus x. So in place of 1 plus x square till infinite, you can write 1 divide 1 minus x. So x power 15 multiplied 1 minus x power minus 5. And for this we know the formula that 1 minus x power minus n equals to summation of k equals to 0 to infinite c n plus k minus 1 k x power k. I already explained this during previous lecture, just go through that, and that we can expand as 1 plus c n 1 x plus c n plus 1 2 x square, like this. Now just substitute this in place of 1 minus x power minus 5. In place of n right? 5. So x power 15 1 minus x power minus 5 equals to x power 15 summation of k equals to 0 to infinite c 5 plus k minus 1 k x power k. Now 5 minus 1 it's 4. So x power 15 summation of k equals to 0 to infinite c 4 plus k x power k. And we need to find x power 20. Here is x power 15. If it will be 5, 15 plus 5 is 20. If this k value will be 5, then we'll get x power 20. So what we'll do, in place of k, write 5. We got x power 15 c 95 4 plus 5 9. So c 95 x power 5, and c 95 after solving we got 126. So 126 multiplied x power 20. And question is, what's the coefficient of x power 20? It's 126. Let's see last example. Example 11. Find number of solution of E1 plus E2 plus E3 equals to 17, where E1, E2 and E3 have non-negative integer with 2 less than equals to E1 less than equals to 5, 3 less than equals to E2 less than equals to 6, and 4 less than equals to E3 less than equals to 7. So we need to check how many way we can get x power 17 from the explanation. And what will be our explanation? E1 range from 2 to 5. So x power 2 plus x power 3 plus x power 4 plus x power 5. Then E2 range from 3 to 6. So x power 3 plus x power 4 plus x power 5 plus x power 6. Then E3 range from 4 to 7. So it will start from x power 4 and end at x power 7. X power 4 plus x power 5 plus x power 6 plus x power 7. So to find solution E1 plus E2 plus E3 equals to 17, we need to check how many way we can get x power 17. That should be 1 from E1, 1 from E2 and 1 from E3. Like x power 5, x power 5, x power 7. 5 plus 5 plus 7. It's 17. This is one way. In another way, we can get 5 plus 6 plus 6. 6 plus 6, 12 plus 5, 17. Is there any other possible? Yes. 4 plus 6, it's 10 plus 7, 17. So there are total 3 way we can get 17. So x power 17 coefficient is 3. That's why there can be 3 solutions. With this, I am finishing generating function. Also the combinatorics. Also you can say discrete maths. Next there will be engineering maths like linear algebra, calculus, probability. If this lecture is helpful for you, please like, share and subscribe. Thank you.